What's up, math scholars? It's Wednesday, and I'm here with my first period class. They're the best in the whole wide world. JACKSON. They didn't have a joke for today that's a bit disappointing, but that's okay.
Who's excited for math?
All right, who's excited to do our study guide today? Woo! Who's excited that we have connections today? Woo! All right, so we're going to try to stay on track so we don't run out of time since we're on connection schedule. All right, I'm going to underline my keyword so you don't miss any keywords. The first keyword is directly. What does directly mean? Multiply. So I put a little multiply above the word directly. And what does square mean?
2.
The second power. So it's going to be P varies directly as the square of M. And don't forget about your constant. I kind of walk you through the steps by doing step A, step B, step C. You know what I mean? So step A is write your variation equation. Step B, this is what I would always call the green step. Continue reading. You'll come to the next two numbers that normally go with one another. P equals 32 and M equals 4. So you put those numbers in. And then we're just going to solve. What's 4 squared? 16. And then how do you move your 16 over?
Subtract.
Divide. You got to divide. It's a multiply.
Oh my god.
I know. Gosh, this is a bad day, but it's okay. 32 divided by 16 is 2. So that answers part B. That would go on answer blank B. You're going to have 3 answer blanks here. Answer blank A, answer blank B, and now we're going to do answer blank C. They don't have an answer blank for that pink step, but I always make you do it. The pink step is just rewriting your original equation with the 2 and for K. And now we're on our black step, finding P when M is 8. Sounds like Nathan already typed it in.
You were asking us what it was.
Oh no, it looked like a lot of people were still writing. I didn't want to go too fast. So 64 times 2, Nathan assures me, is 128. That is your answer blank C. All right. Y varies inversely with X. So I just found the key word. Inversely. Well, what's that keyword mean? We're going to be using division. Yep. So here's my blue step. Y varies inversely with X. The constant goes on top all the time, but your X is going to go on the bottom because of the inverse. All right, let's continue our solving journey. If Y is -6 when X is -4, stop right there. Put those two numbers in and solve for K. How will we move that -4 to the other side? Multiply. Positive 24. Very good. That's your answer to step B. That's step B. This was step A. I'm going to do the pink step, even though they're not asking me to. And that's just plop that 24 in for K. And now we're ready for that very last step. Finding Y when X is -3. Finding Y when X is -3. Yep. -8. How are we feeling? Scholarly so far? Ready?
The wattage rating W in watts of an appliance varies jointly with the square of the current and in the resistance R in ohms. If the wattage is 250 watts when the current is 2 ampere, and the resistance is 5 ohms, find the wattage when the current is 6 and the resistance is 8 ohms.
Thank you.
Thank you.
That was actually a radio star. He's very famous, and he came to make a guest appearance
We can't
today.
say his name.
We can't say his name though.
Cowboy.
All right, the wattage W varies jointly. Do you remember what jointly means?
No.
Multiply. Jointly is just like direct, but there'll be more than one variable. With the square of the current I and the resistance R. And I didn't see anything about a square or cube on R. So our equation is that W is going to vary jointly with the square of I and with R. Now I is in amperes and R is in ohms. So I kind of labeled this 2 as my I and this 5 as my R. They're kind of confusing you by calling ohms the resistance, you know. You would think it would be O. All right, we ready to put some numbers in then? 250 is a wattage. That was easy. But 2 ampere is actually in current. So that's your I value. And then 5 is actually resistance. So that's your R value. So that's going to be your setup to solve for step B. Look good?
Yeah.
What's 2 squared times 5? 20. So I'll divide both sides by 20. Think that's a decimal. 12.5. There you go. All right, so that was the answer to part B, finding K. Now I still have another job. I'm going to do my pink step, just because I love that pink step. Putting that 12.5 in for K. And now we get to finish our black step. Finding the wattage when the current is 6, just remind yourselves that that 6 is an I, and the resistance is 8, so that 8 is an R. So we're going to put the 6 in for I, and the 8 in for R. I'll need you guys to type it in for me.
3,600.
3600?
Yep.
Oh wow, it worked out way better than I thought. And that would be the wattage W. P varies directly, that means multiply, as the square, that means I'm going to be squaring n, and inversely, that means I'm going to be dividing the cube of m, so I'm going to be cubing m. There's a lot going on in this problem. Whew. For one ticket, can somebody tell me what my equation setup will look like? Let's go with Zoe. At the end of the third on the top or bottom. Good. So the n squared goes on top, it's direct. The m cubed goes on bottom, it's inverse. So perfect. All right, let's keep reading and find some information. These are our 3 numbers that are going to go together to help us solve for K. So 0.3125 when n is 2 and m is 4. Now make sure you're using these as actual exponents and you're doing your exponents correctly. For example, what is 4 to the third? Don't botch that calculation. What's 4 to the third? 4 times 4 times 4. Okay. And then 2 squared is 4. What do you think we should do next? Multiply by 64. Very good. I'll need your help with that.
20.
Is it 20?
Yeah.
Perfect. And then what do you think we should do next? Yeah. So K is 5. How's that sound? I'm trusting the student calculations. I don't have a calculator in my hands, so it makes me a little nervous. So that's your answer to part B. And now we will put that 5 in for K. And that's my pink step. And lastly, finding P when n is 6 and m is 2. Who's typed that in for me?
45 over 2.
Which is for those decimal people in the room. 22.5. All right, it's graphing time. So it looks like they're asking for asymptotes. They're not asking for any x-intercepts, so we don't need to like set our top equals 0. How will I find my vertical asymptote, my x equals asymptote?
Set bottom to 0.
Set the bottom equals 0 and solve. You're being scholarly today. All right, so I'm going to solve this. Adding that 4 to the other side would give me a positive 4 over there. And then dividing both sides by 2 would give me 2. So I'll go ahead and sketch that in vertically at 2. Please draw all your asymptotes in with vertical lines for me, okay? And horizontal lines too. All right, do you guys know how to find the y equals asymptote?
The degrees.
What's the degree on the top? M. What's the degree on the bottom? N. So if m equals n, you do your y equals A over C trick that we learned 2 days ago. So A is the coefficient on the top, C is the leading coefficient on the bottom. So 6 over 2. Y equals 6 over 2. That's 3. And let's go ahead and draw it in. And while you're drawing your asymptote in, I better fire up my calculator. I haven't even turned it on yet. Hello, we're back. My calculator's turned on, and I went ahead and graphed it. If you are looking for that fraction button, it is alpha, y equals button, and then number 1. So that'll help you get those fractions in there. It looks like my branches are up in the upper right and down in the lower left. And then what do you guys think my domain is? Negative infinity to infinity, excluding. Good. You always want to exclude whatever x value you have for your asymptote from the domain. And then range, negative infinity to infinity, excluding 3. All right, very good. Ready to move along?
Yep.
The next one looks really easy. I just glanced down at some papers. It's just negative 8 over x. What's that negative sign do? Do you remember?
Switches the graph.
So we're just going to switch our branches. So I'll go ahead and let you graph it so you can see. But there's really no shift to this one. So do you know where the asymptotes are going to be? Just at 0 for both. Can't get much easier than that. So we got our branch in our upper left. We got our branch in our lower right.
Wow, wow, wow.
And there's no shift or anything. So go ahead and sketch your asymptotes in. Yes, I will take points off if you don't sketch your asymptotes in. You have to have those dotted lines in there for every single hyperbola. It's 0 for both.
How many points is that?
I haven't really made my answer key and assigned points yet for the paper pencil board version. Domain, negative infinity to infinity, excluding who? And the same exact deal on the range then. Okay. We are on number 7. This is one where there's really a definite vertical and horizontal shift. You can get those information straight from looking. So let me just point. How would that number affect the shift? It's going to be opposite of what you'd expect. So I think I heard Madison say it. Right 4. Now right 4 will affect the vertical asymptote. It normally lives at 0, straight up and down at 0. But now it's going to live over here at x equals 4. Does that make sense? And you can think about it. You can also set the bottom equal to 0 to get that number. If I would set x minus 4 equal to 0 and solve, I'm going to get 4. Because 4 is a number I cannot put in for x. Because then I would be dividing by 0. How would this number affect the shift? Down 5. And so that asymptote that's normally running horizontally through 0 is now running down here through negative 5. Y equals negative 5. How are we doing on our shift? Good?
Yep.
Oh my gosh, we're golden on time. We only have 2 more after this. I was nervous. You never know how it's going to go. All right, so alpha, y equals number 1.
This is a weird one.
Oh, is it?
That looks weird.
It should just be a hyperbola. It shouldn't be like a crazy thing like yesterday.
It just looks weird. And the homework ones were crazy.
The homework ones were really crazy. But this is just a hyperbola. Oh, it's kind of just really, really smushed in both the asymptotes. So when I draw it, I'll just draw it super smushed into the center asymptotes like that.
Oh, touch the asymptote.
Oh gosh, you can't touch your asymptote. You get electrocuted. It's an electric fence pretty much.
Oh, touch your other asymptote.
Oh no! This is a terrible day. There. Okay, we're doing better. All right, domain, negative infinity to infinity, except for who?
4.
4. Domain stands for x. You want to exclude the x asymptote. Range stands for y. You want to exclude your y asymptote. Negative 5. Okay. We are on number 8, our last one on the study guide, but we are adding on to number 9, so we're not quite done yet. Don't get too excited. We added on the number 9 before we even started. All right, our x-intercepts. This is our whole, we got to do the whole process here, the whole 3-step process on your little sheet of paper. What is step 1? Set the top equal to 0 and solve it. So we're going to move that 25 over. And then what are we going to do? Square root. And that's going to give us positive 5 and negative 5. So just please keep in mind that x-intercepts are nothing more than points. They're crossing points where the graph will cross. So you'll just put a little dot here, and you'll just put a little dot here. And you will receive points tomorrow for putting those points on your graph. Haha.
Haha.
All right, yeah, hey.
Are your x-intercepts, is it always like positive, negative?
Only if you use a square root. You know, if you don't use a square root, then no. All right, asymptotes. Our x equals asymptote. That's our vertical asymptote. What do we do mathematically to get that? Set your bottom equal to 0 and solve it. So y minus 4 equals 0 would give me a solution of 4. So there's one vertical asymptote at 4. I'm getting a feeling this is going to be a weird looking graph. Perhaps.
It's not weird, it's just weird.
It's not weird, it's just weird. Okay.
It's like normal, but it's weird.
All right, I was talking to Emmy a couple minutes ago. This is one where the degrees don't match. You have to do the m and the n trick and then look at our chart. So here's how you do it. M would be the degree of the top, which is 2. It's the highest exponent you can find. And then n is the degree on the bottom, which is 1, the highest exponent you can find. So you want to look at the chart for where m is greater than n, and there's an entry on that chart that you can read about it.
Has no horizontal.
When m is greater than n, the graph has no horizontal asymptote. Right, so that's why you need that chart, and that's why I copied it straight on your quiz. It'll be right there on the quiz first thing.
Thank you.
That way I don't have to worry if you wrote cheat sheets on the back of your little piece of paper. Because people are like, can we write stuff on the back you'll never see? And I'm like, oh, I'll just copy it on there for you. I know, they shouldn't have sent it. Graphy graph. Alpha, F1, number 1. Graph World is so great. Don't forget to charge your calculator for tomorrow and your Chromebook. You guys have to charge everything for quizzes, huh? Don't forget to charge your calculator for the ACT.
And your phone.
No, not your phone.
Yes.
You can use your phone on the ACT.
Yeah, you can on the quiz though.
No, you can't.
Oh, I do.
No, you can't.
Oh.
So this is a weird looking one. It's kind of like an hourglass sideways thing. Reminds me of an hourglass.
Me too.
80 frames per second.
All right, what are we going with for domain? Negative infinity to infinity. Are we excluding anybody? Yep, excluding 4. And what about range? Looks to me like it can go everywhere up and down. There's no exclusions. I don't see anywhere we can't go up and down because there's no horizontal asymptotes. So, all right, I did add on that one question because there's a Polaris question like this, and my study guide didn't have a question like this. Does this chart show inverse variation? If yes, find the missing blank. We did this in the lesson, but I didn't know if you remembered it.
Is this the one we have to type into the graph with your calculator?
No, easier than that. So let's think about what we know about inverse variation. This is the equation for it, right? If I would multiply this x to the other side, we could discover that x times y would always equal a constant number. Okay? And so what you can do is you can just check your products of x times y. So in this case, what is x times y? In this case, what is x times y? So we're going to check all these pairs, making sure all these pairs equal 24. Does this pair equal 24? Does this pair equal 24? So this pair better equal 24. What's the question mark going to be?
4.
6. Okay.
I knew it was 6.
So that is how you can check for inverse variation, making sure your product of your pairs is always a constant number. Okay? Well, we finished in plenty of time. I'm so proud of us. Thanks for watching the video. If you want to come to a study party, they are after school today and before school tomorrow. Goodbye.